Okay, let's dive right into this. Think about taking the perfect photograph. You have to find the exact right angle, right? You have to frame your subject to highlight the absolute key evidence while cutting out all the background noise. Well, Cambridge mathematics examinations are exactly the same. Mastering why a geometric progression has or does not have a sum to infinity is absolutely essential for your Cambridge 0606 additional mathematics success. And honestly, it's because this specific concept appears in practically every single exam series. It's foundational. But as we're going to unpack today in this explainer, it is a topic where so many incredibly smart, well-prepared students completely miss out on easy marks. Why? Simply because they don't frame their explanations the exact way the examiners are looking for. They've got the raw math, but the angle is all wrong. We are going to fix that right now so you can walk into that exam hall with total confidence.
Here's our roadmap for today. We are covering the infinite challenge, the core principles, the procedural framework, those critical examiner alerts, and finally, the evaluation criteria. Let's get moving.
Section 1. The Infinite Challenge.
So, picture this. You're sitting in the exam hall. You open the paper, see a geometric progression question, and instantly a wave of relief washes over you. The math itself feels entirely familiar. You know your formulas, you've done the practice papers, but then you get to the final part of the question and it asks you to explain your result. Suddenly, that relief vanishes. Why is phrasing that final answer so difficult? Well, what's really interesting is that this isn't just a question I'm throwing out there. This is the exact issue senior examiners bring up year after year. They specifically note that candidates consistently struggle with the precision of language required here. You might have a student like, let's call him Alex, who just overloads the page with raw mathematical facts but provides zero actual analysis. Or another student, maybe Sam, who rushes through, sees the numbers, and completely misses the specific requirements of the command word. If you can't clearly articulate the distinction between the mathematical condition and its real-world effect, you are going to drop marks no matter how good your algebra is.
The crucial thing to understand here is that Cambridge isn't just looking for a final number on the page. When you see that command word, explain, they are testing an entirely different set of skills. They are actively evaluating your logical reasoning and your analytical depth over just, superficial breadth. You literally cannot just write down R is less than 1 and expect full credit. You have to explicitly connect the analytical dots to prove you actually comprehend the underlying mechanics of how the progression works. Think of it like the Peel framework you might use in other subjects: point, evidence, explanation, link. You make your mathematical point, you provide the numerical evidence, you explain the condition, and you link it back to the question. Before we continue and really break down how top students do this, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, moving on to Section 2, Core Principles.
Let's completely shift our focus from just doing the math to actually demonstrating true, undeniable mastery. Top candidates, the ones consistently hitting those highest grade boundaries, share some very specific characteristics. They never just blindly memorize formulas. Instead, they build a connected, conceptual understanding of the math. The Cambridge syllabus explicitly points out that top-performing students can take their knowledge and transfer it to completely unfamiliar contexts. They can easily navigate distinct cognitive domains. What does that actually mean? It means moving fluidly from basic knowledge to practical application and straight up into deep analytical thinking. So when a geometric progression is hidden inside a weird real-world scenario, like a bouncing ball losing height or a complex compound interest problem, they don't freeze up. They just rely on their fundamental principles, strip away the background noise, and solve the core problem.
Which brings us to Section 3, the procedural framework.
Okay, this is where we get into the really actionable stuff, the method mark strategy. Having a reliable step-by-step process is basically your safety net. It practically guarantees you pick up marks, even if you make a tiny, silly arithmetic error somewhere along the way. Here is the exact workflow you need to drill into your brain. Step 1, deconstruct the question. What is the command word actually asking? Step 2, extract your relevant data. Get your first term, your A, and your common ratio, your R, out of the text and onto the page. Step 3, select your analytical framework. Are we proving convergence or divergence? Step 4, execute with crystal clear mathematical notation. Do not be sloppy here. And finally, Step 5, present your conclusion using the correct terminology. By strictly and routinely following this framework, you are directly developing the professional mathematical habits that examiners explicitly look for and reward with top marks.
Now, under exam conditions, with the clock ticking down, it's easy to panic and forget your structure. So to lock this framework in, I highly recommend using a memory hack. Create your own mnemonic using the first letters of those key steps we just talked about. Deconstruct, extract, select, execute, present. DESEP. Make it funny, make it weird, make it something that will immediately pop into your head when the pressure is on. Seriously, take 30 seconds right now to think of one. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's jump into Section 4, Examiner Alerts.
We are pulling back the curtain on the actual Cambridge Principal Examiner reports. This is the ultimate cheat code because year after year, examiners report that there are exactly 3 critical mistakes candidates repeatedly make. Let's make absolutely sure you aren't falling into these traps. Here are the 3 massive red flags straight from the examiner's desks. First, confusing cause and effect. Second, forgetting to check format and presentation. And third, providing generic answers that aren't specific to the given context of the question. Look, if you write a textbook definition that doesn't actually mention the specific variables or scenario in the question, the examiner cannot give you the mark. A lack of context and messy formatting will just slowly bleed your marks away. But the absolute biggest, most devastating trap by far is that first one, mixing up cause and effect in your explanation.
Let's really break this down because it's the core of the whole topic. You must clearly distinguish the mathematical trigger from its resulting effect. The cause is the mathematical rule, specifically that the magnitude of the common ratio is strictly less than 1. That's the condition. The effect is whether or not the geometric progression actually converges, and therefore has a valid sum to infinity. Stating one without clearly, explicitly linking it to the other is exactly where those marks evaporate into thin air. You have to clearly state on the page that because the magnitude of r is less than 1, therefore the sum to infinity exists. It's a direct cause and effect relationship, and your wording has to reflect that perfectly.
And because candidates consistently confuse this terminology, the golden rule straight from the principal examiners is this: always explicitly define your terms before you write out your extended response. Never just throw the letter R onto the page and casually assume the examiner knows what you mean. You have to write where R is the common ratio right there in your explanation. It seems minor, but this level of absolute clarity is what proves to the examiner that your analytical depth is sound and you aren't just regurgitating a memorized symbol.
Finally, Section 5, the evaluation criteria.
We've talked a lot about the math and the framework, but let's look at how you actually elevate a standard passing answer into a top-tier maximum mark response. Notice the progression on this table. Lower-level answers stay stuck in that descriptive tier. They just extract data from the text, write down a formula, and plug numbers in. But higher-order assessment objectives demand that you climb that ladder. You need to be analytical by interpreting the relationships between the numbers, and ultimately, you need to be evaluative. In math, being evaluative means justifying your conclusions. When you're explaining the sum to infinity, that means logically justifying why the mathematical condition guarantees your result.
Read this quote. It's straight from the source. This is your ultimate benchmark. Justifying decisions with evidence. In 06006 Additional Mathematics, your evidence isn't a quote from a book. It is your clear algebraic manipulation and your precise mathematical terminology. Show your work, explicitly state the magnitude of the ratio, and clearly tie that concrete numerical evidence to your final written explanation. Don't leave the examiner guessing. So, let's bring this all together into a final system you can use. To guarantee top marks, follow that 5-step procedural framework every single time. Lean heavily on the method mark strategy by showing absolutely every step of your working. Avoid that classic, devastating trap of confusing cause and effect. And always justify your decisions with clear mathematical evidence. Students who actually implement these specific strategies see an average improvement of 2 grade boundaries. But you only get there if you practice consistently. So here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Also, drop a comment below with your target grade for mathematics and the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here. See you in the next one.